If you've ever driven an electric car, you've probably enjoyed the instant torque and silence, but you may have also noticed the subtle vibrations, strange noises under heavy load, or questions around long-term reliability. These are often overlooked, but they're all symptoms of a deeper problem that most people don't talk about. At the heart of it is one glaring issue. Almost every EV on the road, including nearly all Teslas today, relies on permanent magnet motors filled with rare earth elements. These materials, like neodymium and dysprosium, are expensive, toxic to mine, and tightly controlled by China. That monopoly doesn't just hike up prices, it limits innovation and puts the global EV industry in a geopolitical chokehold. But what if Tesla has already found the escape route? Insider whispers and engineering breadcrumbs suggest that Tesla is secretly working on a next-gen electric motor for its upcoming 2025 Model 2, one that completely removes rare earth elements from the equation. This rumored water-cooled induction motor is no simple tweak. It could be the EV industry's biggest shakeup since lithium-ion batteries hit the scene. Tesla's VP of Powertrain Engineering, Colin Campbell, hinted at this breakthrough during Tesla's Investor Day. He revealed that Tesla's next-gen drive unit would not use any rare earth materials at all. That's a seismic shift. And if true, it's not just an innovation, it's a statement. A statement that Tesla doesn't want to play by China's rules anymore. What's the problem with today's EV motors? Most EVs, including the Tesla Model 3 and Model Y, use permanent magnet synchronous motors, PMMs. These motors are known for their efficiency and torque, but they come at a steep cost. They're packed with rare earth materials that are costly, difficult to recycle, and environmentally devastating to extract. According to the International Energy Agency, IEA, China controls around 87% of rare earth refining and over 60% of mining. That's not just dominance, that's near total control. In 2023, when China limited exports of gallium and germanium, it sent shockwaves through the tech world. What happens if they do the same with neodymium? Prices for these materials are volatile. Neodymium oxide prices more than doubled from 2020 to 2023. Plus, the environmental toll is horrifying. For every ton of rare earths mined, there's 1 ton of radioactive waste, tens of thousands of liters of acid runoff, and mountains of contaminated tailings. Tesla's game changer, the rare earth-free water motor. Now, Tesla is reportedly working on a radical new motor design that does away with rare earths entirely. This motor uses electromagnetic induction through copper coils, rather than permanent magnets. It's an idea rooted in simplicity and sustainability. Copper is widely available, easier to recycle, and comes with far fewer environmental and geopolitical risks. The motor will feature a closed-loop water glycol cooling system that regulates heat far more efficiently than traditional air-cooled systems. Think of it like liquid-cooled gaming PCs, but scaled up for a car. The motor runs cooler, lasts longer, and doesn't suffer from performance drops under heavy load. Tesla's system is reported to maintain optimal temperature ranges, 50 degrees Celsius, minus 80 degrees Celsius, during stress conditions, like hill climbs, high-speed driving, or towing. Smarter, smoother by ditching permanent magnets. The motor also removes the cogging effect as subtle jerks caused by magnetic resistance. Internal tests suggest a 40% reduction in vibration and noise compared to Tesla's Gen 3 motors. That means a smoother, quieter, and more refined driving experience. Even better, the new motor design is lighter and more compact. Tesla engineers have reportedly reduced motor weight by 18% and cut down manufacturing complexity by over 30%. That not only speeds up production, but also makes recycling at end of life far easier. Water-cooled, weather dash-proof. One of the biggest doubts people have about water-based systems is their performance in extreme climates. But Tesla's design uses a pressurized, sealed cooling loop, mixed with glycol and proprietary additives that prevent freezing and boiling. Tests show it can function reliably from minus 40 degrees Fahrenheit to 120 degrees Fahrenheit, handling both Alaskan snow and Arizona desert heat. Sensors monitor flow and pressure in real time, adjusting dynamically based on weather, elevation, and driving style. It's a lesson borrowed straight from space. Where liquid cooling has to work flawlessly under the harshest conditions imaginable, including the vacuum of space. Performance meets affordability. Now here's the kicker. Despite all this cutting-edge engineering, Tesla's Model 2 is expected to launch at under $11,990. That's less than half the average price of a compact EV in the US today, yet it doesn't skimp on power. Early test reports suggest the new motor delivers 370-400 horsepower and over 500 Newton-meters of torque unheard of for an entry-level EV 0 to 60 miles per hour, under 5.7 seconds. That's faster than a Toyota Camry or even some Tesla Model 3 variants, thanks to its lightweight build and smart thermal regulation. Energy efficiency improves by about 15%, meaning fewer charging stops and better ranges, especially valuable in rural or high-cost utility areas, a strategic shift. Not just technical, this move doesn't just benefit drivers, it's a geopolitical play. By removing rare earths from its supply chain, Tesla isn't just saving money, it's breaking free from China's grip and setting a new global standard. Other automakers are taking notice. GM, Toyota, and Ford have quietly filed patents and begun R&D into similar rare earth-free designs. Tesla's success could trigger a wave of independence across Western auto manufacturing. If Tesla pulls this off, it's not just a technical upgrade, it's a strategic realignment of the entire EV world. This might truly be the beginning of the end for China's dominance in rare earths.